Hey sixth graders, just going to do a quick review before we get into our reassessment here in the next couple days. So just sit back and take notes if you need to and listen to this quick review. So then we got into this unit, we started talking about how our system and how Earth's system and how systems interact with each other. And we started by learning about each of the root words, hydro, atmo, bio, and geo, and we talked about how each of these spheres interact with each other. So we have our hydrosphere, which is our water sphere, and our atmosphere, which is our gases and air, and our biosphere, which is our life, our plants, and our geosphere, our rocks, and how they all work together and interact in order to create this system on Earth that we live on that works together. So when our spheres interact, we have different outcomes that happen, and we notice and we observe that we may have some changes to our geosphere or our hydrosphere because of these interactions. For example, in this case, we have a small example of the water, the hydrosphere interacting with the rocks, the geosphere, and over time, the water is going to wear away at these rocks and erode these rocks, and we're going to see different landforms, or in a larger scale, we would see a much larger landform. So we look at these landforms and these changes and these interactions, and we know that there's some sort of geological process that's happening. If you remember, a geological process is a process that makes a change to our geosphere. So a change in our geosphere is a geological process. For example, a landform such as a river or a channel or a mountain. We can look at these geological processes on Earth and compare them to geological processes on other planets, such as Mars, like we did in our study previously. We know that when there's some similar geological processes happening, such as channels or rivers or volcanoes and erosion, that means that is evidence that the same geological process very likely formed the similar landforms. So in this case, we were looking at a channel on both Mars and on Earth, and we were trying to decide whether that channel was formed by flowing lava or flowing water. So we can look at those geological processes, look at the landforms, and say, hey, maybe we think these were formed by the same things or they were formed by different things. We created some models to look into these examples a little bit deeper. So we created a physical model of the flowing water, and we made some changes to that flowing water by elevating it and bringing it down and looking at the channel and what happened to the channel as we changed some of the factors in that flowing water model. So we know that scientists use models to represent and study natural phenomena that we might not necessarily be able to study in the natural world every day. And so we can make physical models, we can like this water model, or we can have computer models or simulation models such as the Google Mars model that you looked at in the first lesson there. So models help us understand and make predictions about how different factors can affect natural processes. For example, we looked in the moose activity yesterday, we looked at the biomes of the area of the boundary waters, and we were able to kind of decipher what would happen by looking at the predictions of the temperatures in the next 100 years. We were able to decipher kind of what we think would happen to the moose if we have those emissions continue to happen. So there was a model that was created in order to make those predictions about the moose and the boundary waters. So we can use these landforms as evidence of things of the history of Earth and then compare that to other planets and celestial bodies. So we can look at the sediments on these landforms that shaped them and look at the processes that formed them, and then help us understand and formulate some observations and some inferences about what we think the landforms on other planets were and how they compare to them. Lastly, we looked at models as a representation of the natural process, but not as exact replicas. So when we created our physical models, they were there in our computer models. They help us better understand and make predictions, like again in the moose example this week. But then also they are not the exact replica, because there are other factors that can play a role, such as the moose themselves being in the climate and other animals. So if we think about that greenhouse that was set up near the Boundary Waters area, we don't know what kinds of life were in there, and other factors is there's no rain or snow and those kinds of things. How are they getting those in there? How are they controlling that? So we have to, those are things that are not natural in the model. So we know that this is not an exact replica. Lastly, we made a scientific argument. So we said we made a claim. We started with a question, and then we made a claim about what we think the answer to the question was, and then we came up with a bunch of evidence to support that claim, and then we clearly explained why our evidence supports our claim. So when we're doing a scientific argument, again, we start with a question, we make a claim, we support it with evidence, and then we use that evidence to kind of come together and clearly explain how those two work together, how the evidence and the reasoning work together. All right. Have a great day. Enjoy your retest, and I hope to read them soon. Happy learning. Remember, today is a great day to learn.